Stars, those immense luminous balls of hot gas scattered across the vast expanse of space, seem like they would be immune to the simple phenomena that affect us here on Earth. Yet, as we peer deeper into the cosmos, scientists have observed that even stars can experience something akin to the familiar human reflex of getting the hiccups. While a star's hiccup is, of course, not the same as the involuntary spasm we feel in our diaphragms, the term is used to describe unusual, unexpected fluctuations in a star's behavior, particularly in its brightness. These fluctuations may not be exactly like the hiccups we experience, but they share certain striking similarities. A star's hiccups are sudden, often unpredicted bursts of energy, like an involuntary spasm that can temporarily alter a star's brightness. This phenomenon is more than just a cosmic quirk. It's a fascinating peek into the life cycle of stars and how they behave when their inner balances are disrupted. To understand how a star can hiccup, we first need to dive into the mechanics of what a star is and how it operates. A star is a gigantic sphere of gas, primarily composed of hydrogen and helium, undergoing nuclear fusion at its core. The fusion process transforms hydrogen into helium, releasing a tremendous amount of energy. This energy radiates outward, providing the light and heat that make stars shine. Meanwhile, the intense pressure from this energy pushing outward balances the gravitational forces that pull inward, keeping the star stable for billions of years. However, this balance can be delicate. Stars are not static objects. They evolve over time, and as they age, the processes that govern their behavior can become unstable. Just as humans experience physical spasms, stars can experience irregular, involuntary shifts in their energy output. These shifts are what astronomers have come to call hiccups. The most common type of star to experience such behavior are variable stars, which are stars that experience regular fluctuations in brightness. These changes can happen for a variety of reasons, but often the cause is an internal instability that forces the star to change its size, temperature, or luminosity. Among variable stars, Cepheid variables are particularly notable. These stars are famous for their rhythmic, periodic pulsations. The cause of the pulsations in Cepheid stars is a complex interaction between their internal pressure and temperature. As the core of the star begins to contract, it heats up, causing the outer layers of the star to expand. When the outer layers expand, the core cools, and the outer layers contract again. This rhythmic process results in the star dimming and brightening in a predictable pattern. The pulsations of Cepheids are an important tool for astronomers, as their regularity allows scientists to measure distances in space. By studying the brightness of these stars, astronomers can determine how far away they are and use that information to measure the size of galaxies and the universe itself. But while Cepheid variables pulse regularly, they are not immune to irregularities. In certain cases, Cepheid stars can experience sudden, unexpected bursts of energy. These bursts might appear to an observer as though the star is hiccuping. They're a sign that the internal balance of the star has been temporarily disrupted, though not to the extent that it causes the star to collapse or explode. But Cepheids aren't the only stars that can experience hiccup-like behavior. Other types of stars, particularly those at the end of their lives, can also undergo irregular fluctuations in brightness. A-type supergiants are one such example. These stars are massive and their internal processes can become unstable as they begin to run out of nuclear fuel. When this happens, the star's core contracts while the outer layers expand. These fluctuations in the balance between the core and outer layers can cause the star's brightness to fluctuate in an erratic manner. Sometimes these fluctuations are sudden and extreme, almost like a hiccup. The star's outer layers might expand rapidly and then collapse just as quickly, releasing a burst of energy. These irregular outbursts are often caused by changes in the star's internal convection currents. As the star ages and its core depletes its fuel, convection currents in the outer layers may begin to shift, resulting in sudden changes in the star's energy output. These bursts of energy can cause the star to momentarily brighten, akin to a hiccup, before returning to its regular behavior. Like a person suddenly jerking upward when they experience a hiccup, the star seems to lose control of its normal processes, momentarily releasing a burst of energy before settling back into a more stable state. While the term hiccup may seem lighthearted, these stellar outbursts are actually important events that provide valuable insights into the life cycles of stars. A star's hiccup can be a clue to its internal conditions and how the delicate balance between gravity and radiation is maintained. For instance, when a star undergoes a hiccup, scientists can analyze the changes in the star's brightness and use that data to learn more about its internal structure. This can help astronomers understand how a star behaves as it nears the end of its life and what the future might hold for it. In some cases, these erratic fluctuations can even signal that a star is nearing a more dramatic event, such as a supernova explosion or the collapse into a black hole. The most extreme form of a star's hiccup comes in the form of a supernova, the explosive death of a star. While not a true hiccup, a supernova shares certain similarities with the phenomenon. Just as a hiccup is an unexpected involuntary spasm, a supernova is a sudden and violent release of energy that results from the core of a massive star collapsing under its own weight. When this happens, the star releases an immense amount of energy in a fraction of a second, momentarily outshining an entire galaxy. A supernova is a rare event in the life of a star, but it is one of the most dramatic and awe-inspiring occurrences in the universe. It marks the end of a star's life and, in some cases, the creation of a black hole. Another fascinating example of a star hiccuping is the occurrence of gamma-ray bursts, GRBS, some of the most energetic explosions in the universe. These bursts are thought to occur when a massive star collapses into a black hole or when two neutron stars collide. GRBS are incredibly brief but extraordinarily powerful. They release enormous amounts of gamma radiation, sometimes brighter than the combined light of an entire galaxy. Like a hiccup that comes and goes without warning, these bursts of energy can appear suddenly, without much forewarning, and then fade away just as quickly. While these events are rare, they demonstrate the sudden and unpredictable nature of cosmic processes and remind us that even the most stable stars can have violent, unexpected episodes. Astronomers are constantly studying these stellar hiccups to better understand the forces that govern the universe. By observing how stars behave when they hiccup, whether through pulsations, irregular outbursts, or massive explosions, scientists can learn more about stellar evolution, the life cycle of stars, and the intricate balance that exists within every star. Each hiccup, each irregular burst of energy, is a momentary glimpse into the complex workings of a star's internal dynamics. These moments are a reminder that even the most majestic, powerful entities in the universe are subject to unexpected shifts, disruptions, and spasms. In the end, the idea of stars getting hiccups is more than just a humorous comparison. It's a way of illustrating the unpredictability of the cosmos and the fascinating, ever-changing nature of stars. Stars, like humans, are not immune to sudden shifts in their behavior. Whether it's a rhythmic pulsation, an erratic fluctuation in brightness, or the explosive death of a supernova, stars remind us that the universe is not a static, predictable place. Instead, it is a dynamic and vibrant system, constantly shifting and evolving in ways we are only just beginning to understand. Stars may not experience hiccups in the same way we do, but the cosmic analog is a reminder of the awe-inspiring complexity of the universe around us.